Welcome. As you can see, we're back over in cam. This is the face plate for the Quarterscale ProMod rear end. Being I think I missed a few things in the last one. I'll go over that briefly here quick. These are the tool paths, the direction the tool is going. This is my table layout. I do believe I did go over that one. Okay, and this is your tool path. With this running in the background, it does tend to slow things down a tad. Rapids. This is the rapid coming in from your origin. This is the direction all your processes is going in. It always runs to your right. That can be altered, but it's not necessary. I want to zoom in here a little bit so you can see what's going on here. If you remember, in the first video was machining the actual housing. Them holes were 0.89 for 440. These holes are just a little bit bigger, so these screws will go through this faceplate material. This outside circle that you see here, that is the actual recess, the countersink. This one here is your 089 thread there, an 089 thread there, 440 thread, 089 screw hole rather. Then this hole here is the same size. It's not countersinked because the bracket will mount here for the torsion bar. It's not necessary to countersink it when it's below the bracket. And the countersink is a couple thousandths below the surface as well. Anyways, if I did, it would still set flush. That wasn't necessary to mess with. So what I'm going to do here is I'm going to head right on over to the simulation. Get started on this one here. I'm going to leave it a little bit big here so people can understand that and you can see. Now what's going on, this is 1/4 inch thick 6061 T6 aluminum. And here we go. I don't remember right offhand how long it takes to run this job. And you can see with the crosshairs, that hole actually looks way too small. That's just in the simulation. And this is drilling a hole for the screw to actually slide down into. I don't remember the dimensions right offhand of what it was, but it's just a hair slop around it, and then it goes to your little holes there around your third member. And then on in the pocket in the center. This hole will be completely cut all the way out for your third member. Gain access to changing your gears and loading everything in the rear end and whatnot. I could have machined that out where it's just wide enough for your gear to pass through. In your opinion, I want to do it bigger like this, just to make it easier to get to. Also makes it capable to run on a larger gear. You could run up to close to pert near a 3-inch gear in it. It's a pretty good size gear. Be a lot of combos on ratios there with taller gears and whatnot. On this video here, we're about 8 minutes into it. This one will run fairly quick. And right now on Z we're at minus 23.62, and it's only going to 25, so one more pass. The outside is a fairly quick process as well. One thing to keep in mind, is some people might get confused on too, is the part sitting still, the crosshairs are moving. Obviously on the mill it's just the opposite. Your Z sets still in the center and your table moves. Those that are kind of new at this might get a bit confused, thinking, what the heck? You get your Z to move all around like that. Some people would think that way, I suppose, but keep that in mind. Probably on the next simulation I'm going to do will be the side view of the 4-link brackets where they're going to bolt to. Okay, now they're doing the countersink. If you look down here, you can see the counter board holes. I named it. This is the countersink, and it's doing. There did a tool change where that same 6 flute. Solid carbide, half-inch end mill with a 3-inch flute length. If you would go with a smaller one here, and you could, because it's only 1/4-inch material and you don't have to have that long flute, but that would throw your radius off. This piece would be either too small or too big, then when you go to match them together, so you have to run with the same size that you did on the actual rear end housing, so they'll line up identical. And this is the same drawing as the other housing. As I've mentioned, I just deleted some of the elements. Gear path, axle path, put in the countersinks, change the hole dimensions, put in all the 3rd member holes, the mounts for them, whatnot. Super simple to do. Once you get the first drawing down pat, duplicate the faceplate like in this case and stuff is it's no-brainer, easy to do. Providing you're handy with CAD, that is, I suppose. CAD's very easy to learn. It's all easy to learn, I think, but being mechanically inclined sure helps a great deal. And we're at minus 23.62, so it should have one more pass. And it is. This was the final pass. And I could change all this in mock when I get this actually start machining the parts as far as my IPM, feed rates. IPM stands for inches per minute. Feed rates, inches per minute, and everything, pec rate and all that could all be changed excuse me, within this program or in the CNC controller program. In my case is Mach 3. And we are done. Pretty much sums up this video. That was a quick one as compared to the first one. 24 minutes, 45 seconds. It's not too bad. Thanks for taking the time to watch this.